I will want us to look at this question and be able to get the right answers. And I'll first read the question to you, then we shall be able to go to the working. And the question is given as follows. The diagram below shows a circle ABC with AB measuring 12 centimeters, comma, BC measures 15 centimeters and AC measures 14 centimeters. So we will go to the diagram and be able to actually represent the information in the question and the diagram. So we are going to have this AB as our first length measuring 12 centimeters. We shall have BC, that is BC, and this BC measures 15 centimeters. Then lastly we have AC, and AC measures 14 centimeters. That is all about that question. And just at the bottom here, there's this first part of that question that says, calculate to 4 significant figures the angle ACB. To 4 significant figures, the angle AC, then B. So they should actually be talking about this angle here. So they want this angle theta, that is angle ACB. So the most important part is C. So the angle at C, the angle at C. So for you to get an unknown angle in a particular type of a triangle, and for that matter, you're going to use a rule called the cosine rule. And if I look at this triangle, and as far as the types of triangles are concerned, these must be called an important type of triangle called a scalene triangle. A scalene triangle has all sides not equal to each other and all angles are not equal to each other. The cosine rule reads a squared is equal to b squared plus c squared less 2bc cos a. And I can decide to just take this letter to this point, that can be our C, opposite to the angle at C. You can have this B and you have length B. You can have this A and you have length A. So that at the end of the day, we are going to actually get this angle at C. And if they talk about the angle at C, I'm going to actually rewrite this equation or this rule called the cosine rule, and it will read C squared is equals to, why do I even begin with C squared? Because we specifically want to get the angle at C. So whenever you have to get the angle at C, ensure that the cosine rule gets rewritten in such a way that the C squared has to begin at the start of that rule called the cosine rule. So we shall say C squared is equals to B squared plus A squared less 2BA, then we shall say cos C. So that our most important angle called angle C is the one to get obtained in this case. So I'll just go to this point and then pick that length C, so that I'll say 12 squared is equals to the length at B, 14 squared, plus the length at A, 15 squared, then less 2 times B 14, A 15, then cos C. So I'll have 144 is equals to 196 plus 225 less. So I'll be able to get the answer to this. So I have 2 times 14 times 15. So 2 times 14 times 15. That gives me 420. Then I'll say cos C. That is very correct. That is very correct. I'll proceed with the question, then I'll be able to have 144, that is 12 squared, is equivalent. Then I'm going to add 196 to 125. So I'll say 196 plus 225. Of course, 14 squared is 196, and then 15 squared is 225. That gives us 421. So the sum of these two can give us 421. So we are going to have is equals to 421 less 420 cos C. So I'll just take 421 on this other side, so that I'm going to have 144 less 421 is equals to less 420 cos C. Correct. So I'll take 144, that is correct, less 421. 144 less 421, that gives us negative 277. So I have negative 277 being equal to negative 420 cos C. So I'll obviously be able to divide both sides by negative 420, so that I have now cos C being equal to, so I'll say negative 277 divided by negative 420, that gives us 0.659523. So 0.659523.8. And for me to get the angle at C, I'm going to get the cos inverse of that. So I'll say shift cos of the answer. That gives me 48.74. So angle C is 48.74. 48.74 degrees. It is always advisable to give your answer as far as any angle is concerned to two decimal places. Preferably two decimal places. So the angle at C is 48.74 degrees. And if you just come to this other part, that is part B of that same question, the question says the radius of the circle. So you're supposed to calculate to four significant figures the radius of the circle. For you to get the radius of a circle, if a triangle has been inscribed inside that circle, you're going to say sine rule will work for us. So for you to get the angle, you're supposed to use the cosine rule. To get an unknown angle in a particular triangle, you have to use what you call the cosine rule. And now for you to arrive at an answer that has to actually involve a triangle getting inscribed inside a circle, you're going to use what you call the sine rule. Preferably the sine rule reads A over sine A is equals to B over sine B, which is equals to C over sine C. So that because we have C and sine C, we can use that. We may not bother so much about using this A over sine A and B over sine B, because angle A is unknown, angle B is unknown. But we have length C and then angle C, so we can use this. This must be equal to 2R. Of course, R stands for radius. So then I can be able to move forward and be able to say, then C over sine C is equals to 2R. Yeah, C over sine C is equals to 2R. So that I can be able to have this, of course, I'll be able to say C, which is 12, over sine C, and that angle is 48.74. It must be 2 times radius. So that from there, we can be able to have this. Correct. Wow, nice. So we'll have this. We will have, so that is 12 over sine 48. So it will be 12 divided by sine 48.74. That gives us 15.96. That is correct. 12 divided by sine 48.74. So 15.963. 15.963. So 15.963 is equals to 2R. If I divide both sides by 2, I'll be able to get the radius of that circle. So that our radius R is equal to, so I'll take this answer, then I divide by 2. That gives me 7.98. So the radius of the circle is 7.98 centimeters. That is the radius of the circle, 7.98 centimeters. And if I have to get to this point of getting the last part getting done, I'm able to get that question. The question says the area of the shaded region, the area of the shaded region. If I have to get back to the diagram, I will actually be able to realize that I'll first get the area of the whole sector, then I less the area of the triangle, I'll remain the area of the shaded region, which is actually in the shape of a segment of this circle. So the area of the whole sector less the area of the shaded region, then I can be able to get the area of that other part. So that means the area of the whole part, then less the area of the shaded region. That gives me the area of the unshaded. So preferably someone can decide to take this line and bring it to the center, then again be able to take this and then bring it to the center. Yeah, that's correct. Correct. And I can say let this one be O. So that if that is the case, this line has been brought to the center, this line has also been brought to the center. Any line leaving the circumference of a circle and then actually being able to end at the center of a circle can give us a radius. And we've been told the radius is 7.98. You must have gotten that as your answer, 7.98 centimeters. That's the radius of this circle. So you can even indicate that on that diagram, 7.98 centimeters as the radius, R radius. Correct. So you can come here and say the radius of this circle is 7.98. 7.98. But now we always know that the arc of a length of a circle, or the arc length, or this arc, or this chord AB, whatever it subtends to the circumference should be half whatever it subtends at the center of the circle. So if this chord AB or this arc AB subtends 48.74 to the circumference, then that means it actually subtends twice that angle at the center of that circle. So I can redraw that diagram here. I can redraw this diagram here, then I can be able to show what you're supposed to do. So this can get redrawn just like that. Look at that. Correct. Then you can have this. Wow, that is the center. So we want to know the angle at this point and the angle at this point. The angle at this point here, let's call this C, this part C. Yeah, this is part A and this is part B. This is the center. So if this is 48.74, that means this should be twice, because a chord subtends an angle at the center which is twice whatever it subtends to the circumference. Okay, so we shall be able to come here and say 48.74 times 2. We want to get the angle at the center, that is 97.48. So the angle subtended at the center of this circle is 97.48 degrees. So the one at the center is 97.48 degrees. But they want us to get the area of this shaded part. We shall just get the area of the whole sector less the area of the triangle. We shall get the area of the shaded region. So the radius of the circle, 7.98. The angle at the circumference of the circle subtended by this chord AB, 48.74. The angle subtended the circumference, 48.74, but the one at the center of the circle, it is twice, of course, which is going to be 97.48 degrees. So we will be able to have this. Theta over 360 pi r squared less a half AB sine theta. That means theta over 360 pi r squared is the area of the whole sector. The area of the whole sector. Then a half AB sine theta, the area of the triangle. Whatever remains is the area of the shaded region, now the area of the segment. So we shall come here and say theta, 97.48. This is the sector I'm talking about. And the angle, the theta is 97.48, twice what is subtended at the circumference of that circle. So over 360 times 22 over 7, that is pi times r squared, 7.98 squared. Then we shall be able to say less a half times AB, 7.90 and 7.98. We should just say 7.98 squared, then times sine 97.48. So let's begin the business of the day. We shall have 97.48 divided by 360 times 22 over 7 times 7.98 squared. That gives us 54.193. So 54.193 less, we shall say 0.5, which is the same as a half, times 7.98 squared times sine 97.48. That gives us 31.569. That 1.569. So just get the difference. 54.193 less 31.569. That gives us 22.624. So that is 22.624, which is equivalent to, of course, to four significant figures, 22.62 centimeters squared. That's the area of the shaded region, or the area of this segment. Thank you for your time, and that's the end of our discussion as far as that question is concerned.